Good morning, everyone, and welcome to our Customer Insights webinar session. First of all, I would like to check that everyone is hearing us well, so please send a message to the chat if everything is okay or if you have any problems with seeing or hearing us. Everything is okay, everyone is hearing okay is what I have here, so we can start. Great. So today our presentation is from the experts at Byggnadsekonomi. Johan, Appelqvist and Jaakko Riekki will share their insights on how to increase productivity on site. And this webinar will be recorded. We will send everyone who is attending the link after this webinar later today to the recording as well. And we will post it in our YouTube channel so that it's available there. We are your hosts today. I'm Riina, Product Marketing Manager at Solibri.
And hello, everybody. I'm Vera. I work as a Regional Sales Director at Solibri.
And as always, please give us some feedback. After this webinar, you will get a link to our feedback survey. We really appreciate all the feedback from you guys and what you wish for the next sessions. And I would also like to thank at this point for all the feedback we have received earlier from the previous webinar sessions. We have read all of them through, and we will do our best that we can fulfill the wishes you have in the future sessions. Maybe good to know for everyone that we have had very versatile audiences in the previous sessions, at least, with very different level of experience on using Solibri. The aim that we have for these webinars is to give inspiration on the different ways you can benefit of BIM or utilizing Solibri. And we are also working on improving our help materials and guides for getting started. You can find these kind of materials from the Learn sections in our website. So please check that out, especially if you're new to Solibri. So here's our agenda for today. We will start with Johan's and Jaakko's presentation. And they will share some examples on how Solibri can be used for scheduling purposes and increased productivity on site. And after that, Lauri, our expert here, will show a brief demo on Solibri and how Solibri classifications can be used. We will also have time for some audience questions in the end. You can send the questions to the chat at any time of the webinar. Now, before we start the actual presentation, we would like to do a quick poll. So our poll today is, what is your expectations for today's session? So let's give you a little bit of time to answer this poll. Are you expecting to learn something new, get ideas for your work? Maybe someone is here just to not having to work with their routine tasks and do something else for a change. Let's see. We are collecting the results. Yes, thank you for voting. Here's the results. So most of you are here to get ideas for your day-to-day work and learn something new, but also to understand how Solibri is used. Great. So now we can get to the presentation, and I will give the floor, so to say, now to Johan and Jaakko.
You can see my screen.
Yeah.
Really great to be here. My name is Johan Appelqvist. I hope we can meet up to your expectations on learning something new today and get new ideas, which more than 70% put as a target for today's session. Together with me today, I have Jaakko Riekki, a BIM expert at Byggnadsekonomi. Me myself, I work as a consultant at the CEO of the company. I've added our mail addresses. Feel free to contact us for any questions. We will have the question and answer session later today, but you can also contact us directly afterwards. And you have our LinkedIn profiles. So please reach out if you see anything that is of interest. Shortly about our company. Byggnadsekonomi, we are a quite small or mid-sized consulting company. We have 16 consultants in 2 offices. We work from Helsinki in Finland and Stockholm in Sweden. We've done a bit more than 300 BIM projects over the last 15 years. I think we trained almost 3,000 professionals in different kinds of trainings, mainly on how to use BIM efficiently in production and how to do efficient scheduling for production uses. Main focuses are on BIM management and BIM coordination on a wide area of projects. We do everything from apartments to business premises, hospitals, harbors, arenas, and area development projects. On the expertise, we work with BIM strategy. We do estimating, scheduling, coordination, and also driving BIM out on the construction site. On the reference side, we have 2 BIM awards. In 2017, we were or gained the BIM Tech Award winner for Finland and Baltics with our Eastern Helsinki shopping center project. And a couple of years before that, OP Valila project was nominated for, or actually winner of Tekla Global BIM Awards for best total BIM project, a 90,000 square meter office building. Other references that might be seen outside of the Nordics is the Tele2 Arena, Värtaterminalen, harbor area, Mall of Scandinavia, largest shopping center in Nordic countries, Amos Rex, Arts Museum, New Children's Hospital, and many other. On today's ongoing projects that we are working on currently, we have several hotel projects. We have area development projects. We have cultural projects such as Tanssintalo, building for dance culture in Helsinki. And we have a huge wood construction office building going on. Just to give a small perspective of what we are working on. Then to the topic on Solibri and how we use Solibri at Byggnadsekonomi. We have 6 floating licenses. We are using it full time in our production. We used Solibri Office for quality checking and assurance on the models. We use Solibri Site for quantity surveying, and we use Solibri Anywhere a lot for communicating with our customers. We developed a lot of processes on gaining efficiency in BIM management to do things in a lean way, a smart way, and a fast way. We run approximately 30 to 40 active projects at the same time right now. We do a lot of site support for our customers on how to use the model, how to use Solibri, and we also provide training classes on the topic. For today's agenda, we're going to talk about BIM technology for production management. We're going to talk about managing the data throughout the project, quality assurance, and then go to some value recognitions and case studies on 2 different paths, one on strategical planning and optimization, and one on the visual planning and communication side. When I talk about BIM technology for production management, we kind of think that it divides into 2 different directions. We talk about the visual communication and using 3D and 4D models for people and parties of the project to better understand the goals and getting a common understanding of where to go and what to do. And we also feel that the visual part of the 3D model really supports lean management methods like last planning. The other part that we work with is the mathematical optimization. And under the mathematical optimization, I would put things like resource-based planning, optimization of production, automation, tact planning, and also all the management of dependencies between tasks, but also dependencies between trades, between design, prefabrication, procurement, logistics, and productions, things that can be driven in a mathematical way. If we start with the visual communication, it's always, or not always, sometimes easy to forget how powerful the 3D model can be just on itself if you make it available for everybody in the project, and if you make it easy to get to. So, like a picture on the right side, this is from one of my earlier projects, Svenska Teatern Theatre renovation in Helsinki. The picture is taken from on stage, so where the actors are when they are acting. So this part of the construction is for the audience, not very often. You don't really know it's there unless you've been building a theater. But you can see how many different trades there are in one single location. And the height of the room here is approximately 17 meters, which means that it's not very easy to get to work at the different places. So when you put a picture like this, you get questions like, where should we start? We could start anywhere, but where should we start? And when we decide where to start, let's say we decide to start in this corner that I have in the picture. Now, who should come in first? Is it the plumber? Is it the ventilation? Maybe it's the painter, or is it the steel structure that needs to be built first? And if we decide who comes in first, now can they work continuously, or will there be breaks? In this specific example, the most probable person to start is the plumber, because you can see there are some pipes in the very upper corner, and they would need to be put there first. After that, the ventilation guy can work for a couple of days, but then has to stop because of the gypsum work that needs to be done around the staircases that you can see in the middle of the picture. When you come to this point, you probably realize that maybe it's not the best idea, because maybe the painter needs to come in first. You need to start thinking about what tools do you need? Do you need cranes? What kind of lifts can we use? Is there any special expertise needed? And all these questions arise from this one single picture of what we are supposed to do. If you go into a 2D drawing world, now the information you have in this one single picture would be spread out of at least 10, 15, or 20 PDFs or DWGs. In this case, we use this visual way of planning very, very efficiently together with the contractors for planning together what to do on this area, what to do on this week, what to do on this day, who comes first, who uses what lifts, and so on. That was the less technical use of 3D and Solibri, even though extremely powerful. The other way, the more mathematical way to use BIM technology for production management is shown in the process here, from going from 3D object to raw planning data. We start up on the left side where we have location and dimensions available in the 3D model. You can see the walls that are with the green color on the left side. Now for each of these walls, you can define the structural type. So what type of wall is it that we are going to be building? In this example, we have a concrete wall with insulation and then some masonry outside. So we define the structural type, and we can use the 3D model to get really reliable quantities of how many square meters or cubic meters we have in the model. And we will also know by location extremely exact data of where in the project the specific object is located. Now, by connecting this one to databases of cost and production rates, we can derive from the 3D model data information such as the need for formwork, 120 square meters, connecting that to the production rate database that tells us that it takes 0.59 hours per square meter, or to a cost database that tells us it's going to cost us €7 per square meter to get it done. Similar for rebar, concrete work, insulation, masonry, finishes, anything that you would need to calculate. Now this gives us the basis, for example, for resource-based planning. We can calculate the duration of any activity on site by using the data of quantity, consumption, resources, and the length of the work shift that we are doing. In this simple example, we have 520 square meters of walls. We estimate it's going to take 0.6 hours per square meter. If we add a crew of 2 persons to work and they work 8 hours per shift, the activity is going to take us 19.5 shifts to complete. If the quantities goes up, so does the duration. If the quantity goes down, so does the duration go down. If we add a crew, we are faster. If we decrease the amount of people working, the time is going to take longer, or the task is going to take longer to complete. This gives us the basis for example, location-based and resource-based schedule optimization. Here an example from a apartment building in Helsinki built a couple of years back, where we looked for the most optimal way to build the 7 frames or 7 apartment buildings in this complex. It also derives data like this. The picture on the left side shows the capacity of the factory compared to the need of steel on site, where you can see that the site's demand exceeds the capacity of the factory, which immediately affects us to either reschedule or produce ahead of time the steel and store it before delivery. If we choose to produce faster and earlier the steel, it will have an effect also on our design schedule, because we need the designs to be prepared earlier. Or on the right side, where we can see installation of prefabricated elements per time or per location, could actually be any work on site that we can predict and produce drawings or graphs like this to show what is going on and what is needed. Now, in order for this to work, we need to work with quality assurance. The geometry has to be reliable, otherwise you don't get the real data. You have to be able to identify the element type so that you know what kind of a wall you're going to build, what kind of a column, what kind of a beam. It has to be, you have to be able to identify it in the model. The content of the information in the specific object has to be reliable. From production point of view, you cannot have clashes. It has to be a design that is out of clashes so that you can actually install it on site. And not just clash-free. You also have to have a model or a design where you have thought about the order of installation so you actually can build it. And finally, you have to look out for the service and maintenance needs so that after the specific part of building is built, it can also be maintenance. Further on, for all this to work and for the quality assurance to work, it has to follow the level of the design development, because we are almost never working in a static environment, but we are working with constantly involving designs. Maybe the best presentation of how to handle the level of development comes from American standardization, where you can see by defining what kind or what level of detail you are expecting at different stages. So like these pictures show, level of detail 200 is a rough design, 300 starting to get details, 350, 400, you have the rebars included. So you can define what are you expecting to find in the model data. When you connect this one with classification, we can see on the left side you have the classification system. You can, for each specific building part, tell what level of detail you need or are expected to get at what specific design stage. So combining the expected level of detail to the milestones and the design phases of the project, where a standard milestone might be the detailed design level, but the standard milestone might also be estimating at this specific date, I'm going to do an estimate on this level of detail, and for that I need this specific object on this level of detail so that I can obtain the data I need. When you do that, and when you have the project under control, and when you truly manage the development of your BIM model, you will have full traceability in your model, which means that every single object has an identification, it has a reliable data content, it has its reliable data on geometry and position, and it connects directly to your cost management, time management, procurement, logistics, and all the way out in production. Then back to Solibri. Now, in order to get the quality assurance done, there's a lot of things that you can do with Solibri. You can do the standard quality checking of the model. So make sure that everybody are using the right modeling tools. You can check for duplicates, for missing elements. You can find all the internal clashes within a specific design trait. You can work with the coordination and check architectural versus structural. You can check mechanical versus electrical, MEP versus architectural and structural, and so on, to make sure that you actually have a clash-free design. And you can work with the information content so that all your set requirements on what data should be in the object actually is there, and there is no contradictory information in it. Classification in Finland mainly use the national classification systems. In Finland, it means the Talo 2000 for architectural. Mainly use Tekla class when it comes to classifying the structural model. We have specific classification systems also for the MEPs and for the electrical works. We also work a lot of with classification based on time and locations, and that we will see examples of from my colleague Jaakko and also from Lauri later on. So dividing the model by locations, by sections, by building sequences, and using that further to classify based on time when something will be produced out on the site. Now, this classification supports a lot. It helps us understand the model much better. It is a basis for building custom rule sets that makes the quality assurance much more efficient and reliable in Solibri. And it's also a requirement for your information takeoffs to get the data you really need and in the format that different parties would like to use the format. And finally, it really brings ease of use into the production to have an easy classification system that can be followed in the model, such as the example on the right side, where you by one click can see all the internal walls in the project. We're going to take a bit of a closer look at this classification and use of classification on one of our ongoing projects. It's Kvarteret Isabella. It's an apartment building, approximately 14,000 square meters, 173 apartments, some commercial premises as well. There are 3 different owners in this project. We have a Finnish architect, Arkkitehtitoimisto Korhonen Penttinen. Project management and site supervision is made by Hahtela, and Byggnadsekonomi is in charge of BIM management and scheduling of this project. In the specific case, we're going to look at the 4D simulation and how the erection of the building framework was done in this project. There was a couple of targets made, so what we're supposed to achieve here. We should get a schedule for the erection of building framework. We wanted to define the order of installation. We wanted to make sure that everybody has a common understanding on how this specific building is going to be built. We wanted to ensure the production and the delivery order, and we wanted to make an easy base for site management and production control in this project. And at this point, I will give the word to my colleague, Jaakko Riekki, who will tell how this was actually done.
Okay, so hello everyone. So first, just a couple of words about the basic process. So we aimed at doing a 4D simulation, sort of a simple 4D simulation about the installation of the prefabricated concrete structure. And what we first did was initial data collection, and the basic process looks like this. So the structural designer created the IFC files of the building and also the design documents. And the design documents went to the contractor who is going to do the installation work, who reviewed them and created an initial plan that was like a simple first version of how he thought that they should install the structure. And we gathered all of this information, so the IFC design documents and the initial plan from the contractor. And okay, thanks. And then combined all of those to create a first draft of the 3D or 4D plan in Solibri. And so after the first draft was created, we reviewed it together with the contractor, with the project supervisor in a workshop. So in the workshop, we went through the plan, the initial draft, and looked at all of the small details, which I will show a little bit better in a moment, and gathered some plan modification assignments, which we then worked on after the workshop. And during the workshop, we used the visualization and other ways of correcting the plan. And yeah, in between the workshops, we created like a second draft of the plan. And in this way, we needed like about three workshops before we came to the point that we could call our 4D plan in final, in the way that it was fully reviewed, and the contractor and the project supervisor were happy with it. So next, I'm going to show it live, how it works in this project. So basically, this project consists of 3 buildings, which I'm showing just one at the moment, because this one has been finished so far. The 4D plan has been finished for this one part, and the second one is ongoing, and the third one is going to come a little bit later on. And the basic idea is to use Solibri classifications to create an order installation of structural parts. And let's take a look at the part whose plan has been finished already. So this is called Britta Maria. The building is a basic housing building, and it's made of cast-in-place parts. What we see in the screen right now is the cast-in-place parts, which are at the bottom of the building, and then the prefabricated parts were planned in the 4D fashion, so that we can use the classification tools to simply review the order of the installation of the prefabricated parts. So quite simply, we just went through the plans, the structural design, and first created the baseline, which we then reviewed in the workshops. So when a building consists of simple prefabricated elements, it is quite easy to create a 4D simulation in this way. Also, I could show you a small example of the powerfulness of this way of doing an installation plan. So, for example, when we go a little bit further, right up until about over here, we can see quite a difficult place, because in the initial plan, the contractor had thought about installing the outer shell walls first. And in this case, we can see that this wall part cannot be installed before the hollow core, I mean, like the elevator core walls, because this one sits on top of this one. So these kinds of things we could grasp during the workshops, and I can just show you how it looks like in the pictures in the design documents. So this place right over here, the contractor, his initial plan was made using these design documents, and just taking a look at this, it is a little bit difficult to realize in great detail the ordered installation, but working in the 3D environment, it is a little bit easier to spot errors like this. So what we did here was to modify the plan so that we added the inside walls just before this one wall part that sits on top of them. So in the finished version, or the reviewed version, would look like this, so that those walls are installed first, and then we continue in a similar fashion. So this is like the powerfulness of a 3D visualization that can be easily understood. So then we just continued on. Otherwise, the building is quite simple to grasp, but other sorts of things that were useful were discussed during these workshops, were like things like safety and logistics, and maybe some required scaffolding for installation of certain elements. And it was the contractor and the site supervisor, well, at least they said that it was a very useful tool for them to actually understand how the work on the site is supposed to go. And so in this way, we can easily scroll through the plan, and since the floors from the third floor upward are quite similar, we could use Solibri rules to copy the same kind of plan from one floor to another. So all of these didn't have to be made manually, but instead we created the basic installation order for one floor, and then used the rules, Solibri classification rules, in a little sort of a clever way to copy the same installation order on the other levels also. And that way up until the 7th floor, it was pretty similar, or the 6th floor maybe. And then from here on, there was some variability in the design. So, or the 7th floor was a little bit different. So all of these kinds of things were taken into account, that whenever there's a little bit of change. So for example, in the 6th floor, we had some delta beams that were not on the lower floors, because some of the apartments are a little bit bigger in the upper floors. So these kinds of things of variability were spotted in the workshops and were planned ahead of time. So each time something different happens, it's always good to be able to plan it in beforehand. So that way we just went through the building all the way up until the last elements, and this way the whole building each of the parts gets its own a number specifying the moment or the order in which it is supposed to be installed. So this way we have a very specific list of elements of everything that is supposed to be done, and this always also serves us in coordinating the designer. So in order the design and also the production in a factory, so we have a complete list of elements that we use in coordinating the designer and the logistics and factory production. So this is in that way a very very powerful way of controlling in great detail the direction of the structure. Okay. So, and also there is the great thing about Solibri is also that we can easily print out the list of these structural elements. So in here we have the same numbered order of the elements, and each of the elements have their own name that we can use to identify each and every one of them individually. And in this way, we can list them out in the same order that they are supposed to be installed, and use that list for all of those coordination purposes. Okay, so I think that's just about the things that I was about going to say. So I think I'm handing it back to Johan.
Okay, now you should see there. You can see my screen. Very good. We were asked also to just briefly tell about potential next steps. So what else can we do? Can we go further than this? The result on the work that Jaakko presented was immediate, which means that the crew on site decided immediately that the following 2 frameworks are going to be done with the same methods. So based on that, I think we did quite okay. For potential next steps, can this 4D simulation be used on a more detailed planning level to communicate order of installation also on smaller parts and objects? We tested it on repetitive bathroom installation in a hotel project, found some pros on it. The visualization and communication is very, very strong. The level of detail, we can go down to the same level of detail needed in TACT planning, the scheduling method. And also Solibri Anywhere is generally used and available at almost every site in Finland. So we have a tool that people are already used to work with. On the cons, we have maybe that the level of detail in modeling is not available, and we had to do some remodeling on ourselves to reach the level of detail needed to plan on this detailed level. And at some point, the lack of automation is also going to increase the amount of manual work. This one, what I'm going to show, we have not yet brought into production. This is just something we are testing, but to give you an idea of what can be done. So the same methodology, same kind of classification, but now you can see that we go in a much more detailed level, and we are in the internal work, we are in the building of bathrooms where we handle each separate work. There are approximately 35 to 40 different works that need to be done in a bathroom construction. Can just as well be used in Solibri in this way and communicated to the site. Conclusions. We think that successful project management requires reliable plans and constant tracking of progress. Planning and tracking of progress requires collecting of data, and the quantities can be calculated efficiently by type allocation using the Solibri ITOs. We think the visualization of a plan has a very high impact on understanding and commitment to the schedules, and that the tool has to be easy to use and available to all parties. The Solibri IoTs form a good basis for the schedule planning. It's a very good basis for optimization. However, this is not a scheduling tool, so you would need an external planning software for the scheduling part. Classification functionalities can be used as a strong support for communication and for communicating the schedules and for agreeing the detailed installation orders on site. That's it from our side, and I think I'll hand over the word to Lauri. Please feel free to contact us, and you can find more about Byggnadsekonomi on Facebook, Instagram, LinkedIn, and on our web pages.
Thanks a lot, Johan and Jaakko, for an inspiring presentation. At least I learned something new, and I hope you online did as well. So yes, we will continue to Lauri's demo.
Okay. Hello, everyone. So Jaakko was presenting how to use classification for the installation order of the elements. So I will give a brief demo on how you could use classification also to classify the BIM model into different sections or different zones. Okay. So, of course, the ideal way of classifying them into different sections, we have here a lot of MEP models. We have a architect model and a structural model in this example apartment building complex. So if we think about that all the disciplines would give for the components a property which would have that which section it belongs to, it would be quite straightforward for us to create a classification with a rule that uses the properties to give the section that it belongs to. Unfortunately, that's probably not the case too often. So what we can use is, if we look at one of the components, all the components have a location, and we can use this as a classification rule to classify the different parts of the building. So for the example I've made, just divided it to the structures that we have in the yard, and then we have the apartment building. And how it looks like in the rules, the classification is actually, this was relatively simple one. So I just actually classified the ones that are in the yard, and then the apartment building is the rest of the of this model. Now, if we look at we have the apartment building here, we can see that, okay, this one part, this should be also part of the yard structures. So how can we then group that also to be part of this to the yard structures? So I would just take the view from above. We can change the projection and how to get the coordinates. We can use the markup tool where we have the coordinate stamp, and if I click here, and we can see that, okay, here this is the exact coordinate of this spot, and then, for example, here we see that, okay, the x coordinate is changing and the y stays the same. So what I will do is I will use this x coordinate to say that everything which is less than 685 will be as part of the yard structures. I'll go back to the settings here of the classification. We'll add a new row here, and here we can remove this, and all we do is set here this to 685. So let's see if it's now part of the So now we got also that part to be part of the structures in the yard. And one trick with this, the newest version of Solibri, is that we can actually, if we are not interested at all, we don't want to see these in our 3D view, we can go to the settings of the classification, and this is the new option, use for model colors, and we want to hide the yard structures from the 3D view. So we give them a color which is fully transparent, and this way okay, it's thinking for a while, and this way we can actually, whatever we do now with the model, they are going to be transparent, so they are hidden from the model. And this could be used for other purposes as well. If you are, for example, delivering your model to someone and you know that they are not interested in certain parts, you can create this kind of setting with the classification. I think we are running almost out of time, so that was my short demonstration. I hand it over to Riina and Pia.
Okay, thank you, Lauri. So next is time for questions, and there are already plenty of them we have received. So let's just start with those. So I will take the first one. Was the time schedule based on the data automatically created? Do you get the question?
I think it was when you were showing your example.
Yes, the data was automatically created. The schedule was not automatically created. So the schedule was made based on the data from the model. Some parts are automated depending on what scheduling system you use. So let's call it semi-automated. All the calculations based on crew sizes, handling of dependencies are to some extent automated, but not fully automated.
Okay. And how about co-class?
Co-class is a Swedish classification system. I showed the Finnish classification system that we use, but every country have their own classifications. It really doesn't matter which one you pick, as long as you pick one and stick to it. So any classification system can be used, and you can also have several classification systems in the same model, as long as you communicate to everybody how to use them.
Okay. Then the next one is, how do you check the specifications of an element for the requirements in IFC or in another way?
There are different or several ways to do it. You can use rules for it, but one of the fastest one is to make an information takeoff that shows you in columns the data that you have required in your project. And then you write out of the printout or in Excel, you can see that everything is there and correct. That would be the fastest way.
Okay. And how are the elements added to a classification group? Do they have a specific for the parameter with for the code value? Is this something that Lauri or Jaakko could take?
There's nothing specific about the 4D in the IFC. The way we used it, we created the 4D parameter with the classification ourselves. So the designers didn't take they didn't create anything about concerning the 4D plan. That's everything about the 4D plan was created by us using the classification system. So I think hopefully this answers the question if I understood it correctly.
Good. And did you manage to link this simulation to some kind of project time management tool like MS Project?
It's not really linked to anything, but we can use the data that we can get out of Solibri in very flexible ways, because we can get the tables out of it. Like the names of the elements in the order of the installation is the data that is the relevant one. So we get it out of Solibri as a table, and that can be used in many flexible ways. I'm sure there's ways to import it into MS Project in some way. We've used it with Vico Schedule Planner, so at least that works in some ways in semi-automated way.
Okay. Then there is a question considering the numbering system. What happens with the numbering system for the building elements if there is a change, say an extra element is coming?
Yeah, that is a sharp question. You have to be a little bit clever about the numbering system. What I've done is basically left out a little bit of room in the numbers, like not used. I start each floor with the number of the floor. So, for example, the ground floor starts with 0, 0, and the first floor starts with 1, 1, 0, second floor 2, 0, and so on. But if there's something that you need to put in between numbers that are consecutive in the order, you could always add a space between the number. Like if you have 135, 136, and you want to put something in between them, you could add a number 135 space 01. So in that way, you can start a new numbering system in between two numbers. But this can become confusing if you use many levels of those. So in the end, what I've done is I've flushed the numbering using Excel, the GUIDs and the globally unique identifiers and Excel in order to flush it in the end. So that's one trick to avoid confusion in many levels of numbering systems. Hopefully this complicated answer gives you some idea of what I've done.
That was a clever answer. So the next question is, so the model needs to be modeled in accordance of how each components are being constructed or installed for accurate scheduling to be achievable?
Yes and no. You don't need it to be modeled according to how it's installed for the scheduling part, but you need it for the visualization part, which you can always drive the mathematics from the objects without details. But if you want to show it visually, then the model has to be more detailed. Part of setting goals for your project and maybe a part of the BIM management to really set targets for what you will achieve with your model and then drive the design from it. So scheduling, no. Visualization, yes.
Okay, thank you, Johan. So we are kind of having just 2 minutes left on this webinar. So the last questions, we will put them on the web page, and you will get the link later on, and also the recording of the webinar, because some of you were asking about that. So next time we have Case Veko by David Giraud, and so you should save the date already to your calendars. You will get the registration link after this webinar. David will share how to automate climate and cost calculations with the help of Solibri and BIM Vision. So that will be very inspiring as well. So thank you for your time. If you have any questions, you can contact us by email. See you in the next webinar.
Thank you.
Thank you.